Good day, guys. Welcome to Calcumind, and today we'll be looking at Bernoulli's equation. Bernoulli's equation is a non-homogeneous equation whereby we have the value of y raised to power 3. This is a sample problem rather, but we have a value which is usually greater than 1 or equal to 1 at the left-hand side. And we know traditional homogeneous equation, there is usually a value of 0 at the right-hand side. So that is the identifying factor of a Bernoulli's equation. There is y raised to power 1, 2, or 3. Just know that the number is usually greater than 1 or equal to 1. So now, these are the techniques. I'm going to be showing you a simple integrating factor shortcut we are going to be using to solve the Bernoulli's equation. So this is a sample problem. The y over the x plus 2x, 2 divided by x, multiplied by y, is equal to x squared, y raised to power 3. And we can decide to choose that n is equal to 3. And if n is equal to 3, we substitute it here. We have gotten our value for z. And if we put it here, we have gotten our value for the z over the x rather. Instead of cramming and going through all the long process of cramming the whole equation, I'm going to show you a technique whereby we don't need to cram this, we'll just walk it through. So firstly, let's divide through by y raised to power 3. We want only x squared to be on this side. So this is 1 over y raised to power 3. You can choose to multiply by 1 raised to power y over 3, or we'll just divide through by y raised to power 3. Still the same thing. So this is dy over the x plus 2 over x y over y raised to power 3 is equal to x squared y raised to power 3. We know that 1 over y raised to power 3 is the same thing as y raised to power minus 3. So this is y raised to power minus 3. Y divided by y raised to power 3 is going to be 1 over y raised to power 2 is equal to x squared. This is 1. This is going to cancel out this. So now we'll be left with y raised to power minus 3 dy over the x plus 2 over x y raised to power minus 2, which is equal to x squared. Now that we have successfully arrived at this point, we are going to be introducing z. We should note that any value that is close to an x, which is close to the dy over the x, this value in the bracket is going to be our z value. So now let's say let z equals to this value. Once you have your dy over the x, 2, if it's 2 that is here, and there's y raised to the power minus something, just know that is your z value. If it's 2 over x, 3 over x, 4 over x, and it's close to a y, that is your z value. Let's begin to differentiate this. This is going to be dz over the x. We are differentiating with respect to the x. And if you have an idea of implicit differentiation, you're differentiating with respect to another factor. You have to add, example, you're differentiating dz with respect to the x. Sorry, you're differentiating y with respect to the x. Once you're done differentiating it and there is no x in it, we are going to be adding dy over the x close to it. So this is dz over the x is going to be minus 2y minus 2. We are going to be separating it from minus 1. So this is going to be minus 3. Since they are differentiating this with respect to s, we are going to be saying dy all over the x. And if you check this out, there is a similarity. I don't know if you're seeing the similarity. This is y raised to power minus 3. This is y raised to power minus 3. There's a dy over the x here. There's also a dy over the x here. But the hindering factor now is minus 2. In order to be able to fully substitute this into this point, we have to multiply this whole equation by minus 2. So let's do that. Minus 2 multiplying this whole equation will be present with minus 2y raised to power minus 3 dy over the x plus 2 over x Let's just simply substitute our y raised to power minus 2 into the, which is equal to z, into the equation. Is equal to, okay, we now multiply our minus 2. This is going to be minus 2 multiplied by 2, we having minus 4. So minus 2 multiplied by 2x is going to be minus 2x squared. So we have been successfully be able to replicate what we have here. So now we are going to be simply substituting dz over dx into this equation. So this is dz over dx minus 4x z is equal to minus 2x squared. Now listen up, this is the most important point whereby most students get confused. I'm going to show you how to use the integrating factor method to walk through this out without going through a more slower, sloppy method. So now, using integrating factor, we are going to be comparing this equation to the standard equation, whereby, let me write out the standard integrating factor equation. This is dy over dx plus p of x y is equal to q of x. So, firstly, we'll find the integrating factor. Then we'll then use the integrating factor shortcut method and substitute the integrating factor into it and find our value of z. So let's do that. It's equal to e raised to the power of integral of p of x dx. So this is an exponent, and we are going to be raising it to a power, whereby we are going to be integrating the p of x with respect to the x. So now, if we compare our values, compare this equation to this. Okay, let's write our z here for uniformity. Let's just use z, but if you look back at our previous videos, we have been using y. So if you look at this equation, the y over the x, the z over the y, that is cancelled out. Px is equal to this, z is equal to this, qx is equal to this also. So we can see that px is equal to minus 4 over x. This is e raised to power minus 4 over x dx. Let's write out our px. Our px is equal to minus 4 over x. Okay, now we are going to be breaking this down. This is the exponent raised to the power of integral minus 4 divided by x dx. So I'm going to be showing you the way to break this down and get a suitable answer that will substitute into the integrating factor shortcut method. So this is, if we are going to take this minus 4 outside the integral, since the minus 4 is a constant, so it's going to be e raised to the power minus 4, 1 over x dx. And you should always keep in mind the integral of 1 over x is simply in x. So just keep that in mind. So it's going to be e raised to power, okay, we have already done that. It's going to be minus 4 ln x. And using the laws of logarithm, if you have a log b, it's the same thing as log b raised to power a. So just use your laws of logarithm to work it out. So it's going to be e raised to power in x, and this is also going to be raised to power minus 4. And one thing about exponents and lane function is that they always cancel out. The lane cancels out the exponent, and the exponent cancels out the lane. So this is going to cancel out. So I of f is simply x raised to power minus 4. Now, I'll be introducing the integrating factor shortcut method, whereby y, okay, we are finding z, so it's going to be z is equal to 1 over I of x, or I of f, anyone you choose to call it, they are both the same thing, is the integral, all in brackets, I of x, q of x, dx, all in brackets. Q of x is simply the value on the right hand side. So let's substitute. Z is equal to 1 over x raised to power minus 4 integral of x raised to power minus 4 2 minus 2 rather x squared dx. So now we are going to be breaking this down and finding the integral to get our value of x. At this point, we can recall that z is equal to y raised to power minus 2. And further in the video, we are going to be substituting this z equals to y raised to power minus 2 into this point and making y the subject of the formula. If you enjoy our videos and you find value from what we are doing, make sure to hit the subscribe button and join the group in the description to follow up on more updates. Let's jump right back into the video. So this is minus 4 and 2 using the laws of logarithm, whereby minus 4, if you have a value, let's say a log x raised to power a multiplied by x raised to power b is the same thing as x raised to power a plus b. That is the idea we are going to be carrying out to simplify this. So we have a constant value, which is minus 2. We're going to be taking it out of the integral. So this is z 1 over x raised to power minus 4 minus 2 x minus 4 plus 2 dx. So let's work it out. This is z. You should also note that 1 raised to power 1 over a minus 1 is the same thing as 1 over a 1 over a. So which is, if this cancels out, it's going to, let me write it properly. This is 1 over a. So it's going to be 1 times a over 1. So it's the same thing as a. That is the same idea we are working with. So this 1 over x raised to power minus 4 is the same thing as x raised to power minus 4. X raised to power 4 rather. It's going to inverse and the minus sign will go away. So this minus 2 integral of x raised to power minus 2 dx. So this is z. We are just, from this point, we are going to be simplifying it. This is x raised to power 4 minus 2. Let's work the integral out. This is x minus 2 plus 1 minus 2 plus 1 plus c. Let's not forget our constant of integration. It's very vital in working out this problem. So this is z, x raised to power 4 minus 2, x raised to power minus 1, all over minus 1 plus c. So this will be z is equal to x raised to power 4 minus 2. This will be minus, we are taking this minus to the numerator. So this is minus 1. And this x raised to power minus 1 is the same thing as 1 over x. So this is 1 over x plus c. So let's multiply that. This is z is equal to x raised to power 4 minus minus is plus. This is going to be 2x plus c. So if you multiply this out, it's going to be 2x raised to power 4 divided by x plus c x raised divided by c multiplied by x raised to power 4 rather. So let's further simplify this. So now we'll be further simplifying this, whereby we'll just cancel out, this cancels out, is going to be x raised to power 3 plus c x raised to power 4 is equal to z. We are then going to write a statement which is, recall that z is equal to y raised to power minus 2. Recall, most students forget this, and this is a very important step that will give you more marks. Z is equal to y raised to power minus 2. So this is going to be 2x squared cube plus cx squared for y raised to power minus 2. Let's further simplify it. We are tasked to find y rather than y raised to power minus 2. This is a vital step in Bernoulli's equation. So y raised to power 2 is the same thing as 1 over y raised to the power 2. So we'll put it here. This is z 2 cubed plus cx4 is equal to 1 over y squared. We'll make y the subject of the formula from this point. So it's going to be y squared is equal to 1 over 2x cubed plus cx4. You might be confused at this point. How were we able to do this? How did we get to this point? We simply multiplied this, cross-multiplied this. This multiplied by this equals to 1. Now we are going to be dividing by the factors hindering y squared, which is this 2x cubed plus this. It's just simple stuff, you know. So now we are going to be taking the square root. To eliminate this square, we are going to be taking the square root of the entire equation. So this is square root of y squared is equal to y, which is equal to the square root, a big square root of 1 divided by 2x cubed plus cx4, which is equal to square root of 1. Using solved equation, the square root is going to take the numerator and also take the denominator. So if we square 1, it's going to be 1 divided by 2 plus cx4 square root. So that is your final answer for this. Y is equal to this. Let's take a recap of the whole equation, whereby we substituted z equals to y raised to the power minus 2 into the equation, found the z over the x, and we should also know that there is an implicit differentiation whereby we need to add our dy over the x. Once we are done doing that, we simplified the equation, and using an integrating factor shortcut method, we're able to further simplify the equation and inserted our parameters into the integrating factor shortcut method, solved for it, broke down the equation, did the necessary simplification, and when we got to this point, we're able to substitute back z equals to y raised to the power minus 2 into the equation and made y the subject of the formula. Thank you for watching the video. Make sure to like, share, and comment.